Okay, so this video I'm going to show you a couple of examples of systems of nonlinear functions. Now when we're talking about systems of nonlinear functions, that's going to include functions that aren't linear. For example, quadratics, exponential functions, cubic functions, anything that simply isn't linear. It could include circles, etc., etc. Okay. Now, for our sake and purposes, since we've been focusing on quadratics, what we're going to do is we're going to simply focus on systems that include lines and quadratics. Okay. So just because it says systems of nonlinear, that does not mean that you can't also have a line included in that system. Okay. So I'm going to show you an example of how to find the intersection points when you have two different functions where one of them is not a line. Okay, so here's the system. We're going to have y equals 2x plus 1, and we're going to have y equals x squared minus 4x minus 3. Okay, so our first equation here is a line. Our second equation is a quadratic. We know it's a quadratic because of the x squared. Okay, now I'm going to show you how to find your solutions algebraically. This is technically the substitution method. Okay, so if you need some more help with this or need to go look up another video, this is substitution in solving this type of system. All right, you can also use elimination and that sort of thing. I'm not going to show you that process at this time, but I can show you that later if you're really curious, or you can look it up on your own. All right, so let's dive into this because this is going to take us some work. Okay, so remember, the whole point of a system, finding the solution, is finding the point or points where these two functions intersect each other. Okay, if you can kind of just visualize, this is going to be a line. We know it has a positive slope, and we know that it intersects at the y-axis at positive 1. This right here is a quadratic. Hopefully you remember that this, because this x squared is positive, it's going to be a smiley. It has a y-intercept at negative 3. So you can kind of get an idea of what your graph is going to look like. Okay, all right, so let's find those intersection points. First, I'm going to start by setting both equations equal to each other. Because they both equal y, that tells me that I can substitute, remember we're using substitution, I can substitute in this equation for the y in the other equation. All right, so that's where I'm going to start. So it's going to look like this. 2x plus 1 equals x squared minus 4x minus 3. All right, now what I want to do is I want to get one side of my equation to equal 0. So I'm going to subtract 2x from both sides. You'll notice when I'm subtracting here, I'm going ahead and lining up my like terms. Makes it easier to do my subtraction. So I'm left with plus 1 here equals x squared minus 6x minus 3. Then I'm going to subtract 1 from both sides. I get 0 equals x squared minus 6x minus 4. All right, so now I've got this equal to 0, and I have a quadratic on the other side. So the cool thing is now I can use all this knowledge that I already have on quadratics, and I can find my x values of the points where these two lines or these two functions intersect. So to find my x values, when I have a quadratic equation like this, I can use my quadratic formula. Remember, the quadratic formula is that negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and remember that finds us our x values. Now, so all I have to do is identify my a, my b, and my c, and substitute it into my quadratic formula. Okay, and again, we're looking for the x values of the intersection points. Okay, so in this case, my a is now 1. My b value for my new equation is negative 6. My c value is negative 4. Okay, so now I'm going to substitute it into my quadratic formula and solve. So opposite b, so that's going to give me a positive 6 plus or minus the square root of negative 6 squared minus 4 times my a, which is 1, times my c, which is negative 4, all over my 2a. A is 1, so 2 times 1. Okay, now I just simplify. All right, so I have 6 plus or minus. Oh, let's write what I'm saying. Remember, negative 6 squared, do not put that in your calculator because it's going to give you negative 36, and that's bad, bad, bad. Wrong, wrong, wrong. We want negative 6 squared. That's 36, positive 36, because negative 6 times negative 6 is 36. All right, and then I'm going to do my 4 times 1, which is 4. 4 times negative 4, which is negative 16. Since I've got a double negative, that's going to be plus 16 all over 2, because 2 times 1 is 2. Add 36 and 16, which gives me 52. All right, so now we find the square root of 52. It is going to be a decimal number, and I'm just going to round it to the 10th place. So 6 plus or minus the square root of 52, which is actually 7.2-ish, okay, all over 2. And remembering, we break this now into two problems, one where we add and one where we subtract. Okay, 6 plus 7.2 is going to give me 13.2 over 2, which gives me 6.6. Okay, and over here, 6 minus 7.2 is going to give me negative 1.2 over 2, which equals negative 0.6. All right, so the x values of my two intersection points are going to be 6.6 and negative 0.6. So what I'm going to do with those is I'm actually going to go back up to my original problem here, and I'm going to take the linear equation, and I'm going to substitute those x values in to get the y values. All right, so let me get a new sheet here. I'm going to do x equals 6.6 and x equals negative 0.6. Okay, remember those are the two values we just found. So now substitute them into y equals 2x plus 1. All right, so y equals 2 times 6.6 plus 1. 2 times 6.6 is 13.2 plus 1. Y equals 14.2. So one of my intersection points is going to be 6.6 comma 14.2. Oops, there we go. Now you can see that. Okay, now I'm going to do this again with my second x value. Y equals 2 times negative 0.6 plus 1. Y equals, multiply that by 2, I get negative 1.2 plus 1. Y equals negative 0.2. Okay, so my second point of intersection should be negative 0.6 comma negative 0.2. All right, so this is where those two equations, that line and that quadratic, intersect. Now to show you really quickly on your calculator, you first start by going to the y equals, hopefully you can see that, and putting in the line, and then the second y is going to be your quadratic, all right, and then you press graph. And what we can do is we can trace and see that where x is 6.6, our y is 14.19-ish, okay? And if we check our work from our algebra, we got that one correct, okay? So that's the first intersection point. And then if we arrow over, here we go, to where x is negative 0.6, and about right there, okay? We can see that x is at negative 0.6, y is at negative 0.2-ish, okay? Which is what we found with our algebra.